We are on the section 10.5, solving exponential and log equations on your page 40. So we have been talking about log, right? So we talk about its concepts, which is what? The inverse of the exponential function, right? That's exponential function. That's the inverse in general, log functions. So we talk about concepts, then we talk about basic skills, add, subtract, multiply, and divide, something like that, right? So for log, to write in a one log, if we have same base, if we add two logs, right? And to write in one log, we multiply the inside, right? If we subtract them, right? Then we write in one log, we divide the inside, right? Then when we multiply a log by something, then to write in a single log, then you move this as a power property. So those properties are basic skills. How do you manipulate the operations, right? Also, we have inverse operation, which is what? If we have like log base b to the some power, right? You can just kind of ignore those. Of course, all the base and the content inside, they have restrictions, right? So base is bigger than 0, base we don't use 1, right? Then also most important part is what? Inside the log has to be what? Positive. Has to be positive number, okay? So we also have another inverse operation. It's like this. B of x, then it's like those. You have x. Okay, so now we are going to solve the equations for the exponential functions and log functions. Then we do some apps. That's what we are going to do today. Then let's emphasize a few things, okay? On your calculator, if you have, say, log, okay, you see a log on your calculator without base, it means what? Invisible 10, base 10. That's the common log we are doing. Okay, also natural log is this way. If you see on your calculator, right, there's ln x. It doesn't have a base here. It means what? Log base with this guy, e. Okay, so e is a number, right? We did the last time. E is what? It's about 2.718 decimals. Right? So let's see. That's the name for those logs. One is called what? Common log. Another one is called natural log. Okay, so we are going to do solving equations for the logs today. Let's see. So let's see some example. Log 100. Can you put this into calculator? Common log, yes, base 10, right? So that means 10, invisible 10, 10 to the what power is 100? That's 2, right? You can either put into the calculator or you can just use your head. Then if log, okay, another way to think about it is like this. Log 10, 10 to the second power. If you use this inverse property, you can see it's 2 as well. Or you just use the basic concept of the hooking by, change this concept to what? The exponent style. So for the basic function, we say f of x, it's a log function, right? It's like log base b of x. Then this is your y, so our y is what? Log b of x. But mainly we write what? B is your base. You do the hook, b to the y power is x. So main concept of a log is what? You translate them back to the exponential style to figure out all your values, right? So mainly is you do the hook. So to find the value for the common log, cube root of 10, what do you think? Okay, so you change back to what? The power style, right? Top is power, bottom is the root. That's cube root. So it's a base 10, right? So for the value, it's like this, right? So your base hook to the answer will be inside. So your base hook to the answer will be the inside. So that will be what? 1/3, right? So 2 to the 1/3 power is inside. Or you can do this by inverse property. So if you have a log 1 to the 1,000, what do you think? So you change to what? To the power style, right? -3 power means the reciprocal, 10 to the 3rd power. So your answer should be what? -3. So you can punch in this to the calculator. You will see the answer should be -3, right? So if you have log -100, you punch into the calculator, then you will see what? Like an arrow or syntax arrow. Things like this. Because why? Because we say log function, all the x's inside, right? All the x's domain should be what? Between 0 up to infinity. See? That's most important restrictions for your log. So you have learned 3 restrictions, right? One is what? The denominator cannot be 0, right? Another one is what? The inside of the even radical, you can be 0 on this one, but you cannot be negative number, okay? Another restriction you have learned 3 things, right? Another is the log. Inside the log needs to be what? Positive, okay? Let's see. So we practice some common log. How about natural log? Okay, for this one. So for your natural log, let's see. If your first one, natural log e to the 7, what do you think? You can punch it into the calculator. Practice that. So then what do we have? That means a log e to the 7. So that would be 7. We need to use those kind of properties, okay, to solve your word problem apps. So if natural log square root of e, so what do? So it's a log base e, right? Then this is e to the half power, so like this. So the answer is half. Good? Okay, and so we went through the basic concepts again, how to find the value of the logs. All right, so then let's see. If we wanted to solve some equations, we are going to solve equations for both exponential and log equations. So let's do some log one first, right? So if you have on your paper, we just use a little bit different symbol. We say m equals log b of x, right? What does that mean? Means what? If you hook, that would be the inside. That means what? bm equals what? X, right? Remember what's your restriction? What's your restriction? The base has to be what? Base has to be bigger than 0. Base cannot be 1, right? Remember that. If I ask you a function of a log, then you have to describe like this, but you have to describe the restrictions as well. Also, x inside the log has to be positive. Okay, so when we solve equations to solve, then the log equations, make sure you check, okay? Make sure you check, because if you have restrictions, when you solve equations like, right, fractions, you have to check the denominator. When you have radical equations, you have to check the result, right? So you have to check the inside the log has to be what? Positive. Okay, make sure you will do that. So let's see some examples. First one, log 3. We do the basic one, all right? Basic log. First, we find the log values, right? Now we are going to solve, is this a equation? It is an equation, right? Then you have 3 places, base, inside, and the value. Then you have to find the value, so you use basic concepts, right? So that means 3 to the 4th power is what? 2x. Then 3 to the 4th power is 81 equals 2x. So your x is what? 40.5. Usually we always use fractions for the accuracy, all right? You keep all the decimals until the end, you round them. Because a log, it has a lot of decimals, so usually we use the approximated value, okay? So log 5x equals 2. How you are going to do it? You still use the basic concept, okay? It means what? Log base e, 5x is 2, right? Now you do the hooking, right? Then what do you have? Your 5x is what? E to the square, right? If we wanted to write it like in the calculus or pre-calculus, we would write your answer equals what? E squared over 5, okay? But for applications, we might want to find exactly, you know, the numbers. So if you use calculator, and you should get e squared, a value divided by 5, you should have something like this. Make sure you practice those, okay? To get exact, you know, close enough a number for it. So what do you think for this one? So you don't have a base means what? Common logs, right? Base 10. Then to find the x, so you do that, right? So you have what? 10 to the 3 power is x minus 5. Then you solve x plus 5 on each side. X is 1005, right? Then you check inside. Yes, it is a positive number. Okay? Then next one, let's take a look. Another one. So think about it. What are we doing? Solving some basic log equations, right? It is a basic. We don't have add subtract in it yet. Just a basic concepts. Then you use the hooking. All right. And let's see. We don't need this. Okay. Let's see next one. Natural log 2x plus 1 equals 2. What's your x value? So how should you start? You need a base so you can hook, right? So you write a log base e, 2x plus 1 equals 2, and you hook it. So what do you have? So you have 2x plus 1 equals what? E to the square, right? So if you do that, then 2x equals what? E squared minus 1, then divided by 2. X is e squared minus 1 over 2. Or you punch into the calculator, you will get a negative 0.4323, something like this. Okay? So, can we use this value? Because it's a log, we better check. So you plug in negative 0.4323 times 2, it's a negative 0.86 something. Then plus 1, still positive. Okay? So to make sure, you will always do this. Okay? The checking. So in general, what do we say? And to solve an equation with one log, see, one side is a log, another side is a number, right? Basic one. So if you solve one side is a log, another side is a number. So one side is a log, right? And another side is a number. So it's a log something. Then this is a number. So all you have to do is what? You will rewrite it as the exponential equation. Right? See, we write a log as exponential equation. We write a log as 10 to the third power. We write this as e to the second power. We write this what? 3 to the fourth power as inside. So if one side is a log, another side is a number, then you can just rewrite it as an exponential equation, right? Once you write it as an exponential equation, then you should be able to solve it, okay? So let's just review some more exponential equation we did earlier, but let's do it again. Okay, so how do we do that? And for example, you have this one, 2 to the x power is 1/8. Remember, how do we solve exponential equation? We say, okay, make two sides the same base. Then we should be able to compare, right? 2x8 would be 2 to the -3 power, same base. So we know x is what? -3, right? That's how we solve exponential equation. What happened if 2 to the 7 like this? And 6x plus 1 equals 8. So we have exponential equations. Can we change to the same base to solve it? What do you think? One is 2, one is 7. You can never make it this, same base. Then what we are going to do? That's where the log comes handy, okay? So we are going to do another way around to rewrite it as what? A log, okay? If one side is log, another side is number, then you write it as exponential equation to solve a log, okay? But when you have exponential equation and with different base, you have no way out, then let's see. If we do this way, we rewrite it as a log equation. If we do that, log base what? 2, right? Which one you put outside, which one you put inside? So 2 to the power, it's inside. So 2 to the power x is inside. So is that your x? Is that what we are supposed to find? The value of x, okay? So if you do that, then x equals some numbers, and how can we solve it? 2 and 7. Then we need to use the log properties. Okay, one of the log properties. We say if you don't have, you don't have the common log or base e, natural log, you cannot use calculator, right? But we say you can use what? Base change formula, like this. So you change it to common log, or you can change it to what? Natural log. Either way, okay? Or you can do that. Then you will find out, then you will have answer 2.8074. Or you can use this one, you will still have same answer. Okay? So because this property of the base change formula, then with calculator, you should be able to find the answer for the exponential equation, okay, with different bases. If we have next one, right? Same thing, we cannot change the same base. So what do? We will rewrite it as a log. Log base what? 6, right? What do you put inside? What do you put outside? So 6 to the hook to the power x plus 1 equals 8, right? So what do we have? X plus 1 equals log 6 and 8. Then you should be able to find this value with base change formula. Okay, it's about 1.1606. Okay, then what's your x? Then minus 1, minus 1, minus 1. X is about 1606. Okay, then how do you know you are right? So you can check. How do you check? See, you can put a 6 here base plus x plus 1. 1606 plus 1. Then as a power, right? You can just punch into the calculator. See, you can get close to 8 because we have rounding here. So you should get very close to 8. You have 8.0001 something or 7.9999 something like that, right? So what are we doing? We are solving exponential equations. With some of them, you have same base. Some of them, you don't. You have different bases. But either way, you should be able to solve it. Before, we couldn't do that, right? Early on. But now, since you learned log, you should be able to solve those. All right. So we just solved more complicated exponential equations. Then let's see, how do we solve more complicated log equations? See if we can figure out. Okay, so let's take a look. First one, this is still basic. Just a single log, another side is a number, right? Then we will rewrite it. So we will rewrite it as what? Exponential log, right? So we rewrite it. So 4 to the second power is 3x. Then you solve x is what? 16 over 3, right? Then if a natural log, same thing, that's a simple one, basic one, you will write log e, 5x minus 7 equals 3, right? Then single log, you rewrite it as what? Exponential equation will be what? 5x minus 7 is what? E to the third power. Okay, then your x plus 7, so 5x equals what? E third plus 7. Then your x is what? Divided by 5. Right? Or you can change it to the decimals. That would be things like this. Good? So if one side is log, another side is number, you should just rewrite it as exponential equations to do it. Right? That's the whole idea. Because we know how to solve the exponential equations. Okay? What happens if you have this one? One side is not just a single log, but another side is a number, right? That's why we learn add, subtract, multiply, and divide, the properties of the log. Can we make this single log? Same base, we say if you make a single log inside, when you add, what are you going to do with the inside? You shall multiply. Is that right? So, do we have a single log now? Yes. If we have single log, we can rewrite it as what? Exponential equation. So it would be x minus 2 equals what? 2 to the third power, right? Which is 8. So that would be x squared minus 2x equals 8. Not a standard form, but what kind of equations we have? A quadratic equation. We go back to a quadratic equation again, right? So x squared minus 2x minus 8 equals 0. So x minus 4, you factor it, right? So what do we have? We have x equals 4, x equals negative 2, right? However, we said for a log function, there is a restriction. When you have a restriction, you need to do what? You need to check the inside the log need to be what? Positive. So before you circle the answer, can you use a 4? 4 minus 2, all positive. But if you use x negative 2, inside of the log becomes what? Negative. So you cannot use. So this one is what? Extraneous, right? So you can only circle one answer. Got it? Make sure you remember it. Right? So if I have a log 3, so 2x minus log 3, x minus 2 equals 4. So we say we want to make one side is a log, another side is a number, then we can resolve it by the exponential concepts, right? So we want to make one log. When you minus, what do you need to do? The inside. You need to divide when you make a single log, right? Then single log, to resolve it, we will rewrite it as the exponential equation. So 3 to the 4th power equals what? 2x, x minus 2. So instead we have a quadratic equation. What kind of equations we have? 3 to the 4th power is 81, right? What kind of equations we have? Rational equations. So that's why at the beginning we reviewed everything you have learned from 152B class to solve a quadratic equation, including what? Rational equations and radical equations sometimes. Okay, then how do you solve this one? Then we say, okay, we can make the denominator the same. You multiply this, right? Then you cancel out what we have. We will have 2x equals 81 times x minus 2, okay? Another way, usually what we do is, if you understand this concept, then we will do the shortcut. Instead of find the same LCD, what do? We will just multiply both sides by the denominator, x minus 2, right? Then this cancel out. Then what do we have? We have 2x equals 81 times x minus 2. We can just multiply both sides by the LCD. Or you can find the LCD, you cancel out, it ends up same thing, right? So then we solve the linear equation. From the rational equation, we change to a linear equation. So 2x is what? 81x minus 162. Then you solve your linear equation. What do we have? Negative 79x equals, right? So your x is 162 over 79. Okay? Before we circle the answer, we need to check the inside of the log. Okay, so this is positive times 2, still positive. If this one minus 2 is still positive, this one is about 2 point something, because 2 times 79 is 158, right? It's about 2 point something. So it's bigger than 2. It's okay. So if you plug in x minus 2, this one is still positive. You have to check the inside of the log. It's still okay, right? So we want to make sure one side is a log, another side is a number. So you can interpret with the exponential equations then to resolve, right? So that's the approach. However, let's see something else. This one is not on your paper. So if we have a situation like this, log 4x plus log 4x minus 5 equals log 4, 14. Okay, what happened? And one side is not a number. What kind of approach you should use? Both have same base. So if we make just simplify the first, make a 1, right? Make a 1 log. So what do you think? When you add, you multiply inside, right? So situation like this side is not a number. You cannot hook it, right? To write it as an exponential equation. But what do you think? Log 4, they are the same. You can just ignore it, right? Just like same base. And if I have log, say 5x equals log 5, 7, what do you think x is? It has to match both sides. So if they have same log and with same base, you can just equate the inside, right? So you can just write x minus 5 equals 14. So what kind of equations we have? Not a standard form, so it's a quadratic equation. Then we will write it in standard form, right? 14 over, then we can write x minus 7, x plus 2 to factor it, right? So x is 7, and x is a negative 2. Then we are going to circle the answer. Can we circle 7? They are all positive. Yes, inside of the log, inside the log needs to be what? Positive. How about negative 2? You cannot do it. It's extraneous. So you only have one answer, right? Okay, that would be this, how we are going to solve some log equations. Okay, same thing as solving exponential equations. They go hand in hand. So let's see how we are going to use the exponential and log functions to solve problems. Okay, so look at your page 42. Let's talk about money first. And compound interest periodically or compound interest continuously. There are two formulas. One is like this. Okay, we just give you the formulas and you don't know why, but just learn how to use it first. Then you need to go to transfer level to learn the reasons. Okay, we say P is your what? Among your own, you owned or earned, all right? It's like your principal. So P is your principal, right? R, usually we always use annual rate. Then, and N is the number of times will be compound. Okay, if a compound periodically, okay, number of time, the interest is compound per year. So if it's, say, yearly, then N will be 1, right? If semi-annually, then twice a year. If it's quarterly, then N will be what? 4, right? If it's a monthly, N will be how many times a year? 12. If it's a daily, then N will be what? 365. Okay? Then this formula, then take a look. Which one is your variable? T is your variable. Depending on those are given, T is what? Is the time, duration of the time. Right? So, T is your variable. Take a look. What's the T's position? Okay? So T is time in years, because we are talking about annual rate per year. So what's the difference? This one is for compound periodically by those how many times a year. Then this one is continuously. That means what? By every day, by every hour, okay? Then P is the same thing as a principal. What's your E? That's the natural log base E, okay? So that's the 2.718 some numbers, right? Then if we say continuously, we need to use this formula. Then let's take a look. For the first one, it says if amount of money for which $2,500 CD deposit, okay? Then if it's paying 10% in interest compound, what? Continuously for 3 years. So which one you should do? If it's continuously, we should use this way, right? So what should we have? P is what? 2,500. Then R is your annual rate is what? 10%. Then we use the decimal. Okay? Then T is what? Say after 3 years. So how much total you will have if you deposit, you put a CD $2,500 for 10% for 3 years. So your A should be what? You just plug in 25 E, right? Base E, R is what? 0.1 times what? 3T. Okay? So you plug in, you find the value first. Okay? So you want to use all the decimals. You can have at least around, at least 4, but usually we use 7, 8, 9 of them. If you can, and you multiply this, then use all the digits as much as possible. Whatever is on your calculator, you just leave them there. Okay, then you multiply 2,500. Only rounded at the end would be what? 3,374.65. Where you to round it to? For money, you always round it to the penny. Then you have to tell me what kind of things we are talking about. Are we talking about, square footage, or the money, or the goats, right? We are talking about the money. So you need to tell me what you are working with at the time. So put your unit of measurement. Otherwise, you get a deduction, right? So you need to know how to use calculator, then multiply them, use the formula, continuous compounding with the base E. Okay? Then let's take a look. Next one. It says, how long will it take for $600 to double if it is invested at 12% interest? That would be nice, right? Nowadays only 2-3%. And if you invest, you want to have a high return. So if to double means what? $600, you want to have how much? $1,200, right? So it is 12% interest. And which one is your interest rate? That's rate, right? So your R is what? 0.12. Okay. Your P is what? $600. Then it says what? Want you to calculate compound monthly. If compound monthly, that means your N is what? Monthly 12 times, right? Then do we know the T? It asks you how long it would take to double it. So we don't know the time. We need to find our time, right? And your formula is say what? A equals P times 1 plus R N to the NT. You can only have one variable you don't know to find the answer, right? P is how much? 600. 1 plus what? R is 0.12. N is what? 12. And 12, do we know the T? We don't. We want to find the T, right? Then we need to put A here so we can find the T. So what is your A? Amount, right? Final amount. You want to double it? You will be what? 1,200. That's how you should do, right? So 1,200 would be what? 600 times 1. That's 0.01. So that's 1.01 to the what? 12T. So what kind of equations we have? Your variable is at what? Exponential position. So we have what? Exponential equation. Exponential equation, we usually have, say, phi equals, say, 2 to the t power, things like that. Then we can solve it, right? We have a single number, then we have different base. So you have too many numbers here. We better get rid of 600 for some reason. Some of you just get stuck there. Okay? You need to change to the style like simple variable at exponential position. Then you can resolve it. So you have what? 2 equals 1.01, 12t, right? So what kind of equations we are dealing with? Exponential equations. So we say, how do we resolve exponential equations? Change to same base. Can we do that? No. If we cannot change to the same base, what kind of approach we should use? You have to use its evil twin, the log, because log and exponents, they are interchangeable, those functions, right? So you have to change it to exponent, to the log. How do you write a log? So you have to do that hooking things, right? Log base what? That's your base, right? 1.01. What do you put inside? What do you put outside? So you hook it to 12t. It's 2, right? Then how do you find your t? You need to do is find the value, right? 12t equals log 1.01 and 2. It's not the common log. Base 10 will come. Base e, natural log. You need to use what? Base change formula. You have to use everything you have learned so far to solve the apps problem like this. Okay, so it would be, you use all the decimals, okay, before you round it. So if computer asks you to use 4 decimals for the answer, you use all the decimals before you round it at the end, okay? So you will use all of them, 71689, right? So it's about 5.80505. Okay. So did they tell us where to run? They didn't say anything. Okay. So you give me close enough. That's good enough. That's how you solve it. Okay. If you want to have $600 on CD to get $1,200 for what? 12%. Let me see, 12% a year, right? That's pretty high. Then compound monthly. How long it takes you to double it? About 5-6 years to double the money. It's no big deal for 600 to 1,200. Then if you run the company for financial reason, if you have 6 million to 12 million, right? That's a big time. Then for 5-6 years, that's a very high yield. That would be a concern for the people who does the investment, right? Okay, we have another one. Here say, same page, 42. If we compound continuously, how long it takes the money to double? Okay, then you will use this formula. A is what? 1,200. T is what? 600. E, rate still same. R is what? 0.12. You want to find the T. Okay? So same token, same thing, you want to write what? Like 2 to the 5 to the x power, simple one. Then one side just have the power with one base, nothing else. So you have to get rid of 600 first, right? So you end up 2 equals what? Right? Simple exponential equation. Then to solve the variable, then you cannot change the same base, so you will write it this way. Natural log E base E, right? What's inside, what's outside? You hook it, you hook it, you hook to that. So this 1 point T to 2. Okay? How do you find this value? Actually, it's on your calculator because the natural log is what? Natural log 2 equals what? 0.12T. Then you have a value. Then you just punch in calculator. So your T is what? Natural log 2 divided by 0.12. Okay? So you use all the decimals. Just punch into the calculator, leave there, then divide by 12. So your T is about 5.762265. Okay. So if we write the 2 decimals, it's about 5.78 years. Okay. One is 5.81 years, one is 5.78 years. Not much difference for $600 to $1,200. If you have a 6 million to 12 million, or nowadays a billion, right? Then the little difference is quite a bit. Okay, different time, a month time, it's quite a bit difference there. Good? Definitely you will have one of those questions, maybe both, okay, for your exam. So practice your homework, make sure you understand them enough to use the formulas at the same time to solve what? Log equations and exponential equations. Same thing, right? Okay, let's look another kind. Okay, on your page 43, it says, okay, the number of victims of a flu epidemic is increasing at a rate of what? 7.5% per week. Okay. All right. I'm just thinking, okay. So that's better than our COVID-19. Okay. So if 20,000 people are currently infected, then in how many days we can expect from 20,000 people to what? 45,000 people will be infected. It's a major concern, right? If they have, say, 0.1% of death, then 0.1%, then that 20 people becomes what? 45 people in a week. Actually, you know, for this flu. So, what do you think? The growth, they say use this formula. Y equals Y sub 0 e to the 0.075 t. It's like our continuous compounding. A to the, what do we have? A to the P to the ERT. It seems similar to that. Among equals or P is a starting point. So Y sub 0 means at the time of zero, sub-zero at the beginning of time. Then E, right? R is what? R is 0.075, which is what? 7.5%. So they give you this formula. It means similar to this kind. It means what? It's continuous growth. Then you will be continuously, infected by other people. Okay, so they have this formula. And how do they develop those formula? Then they collect the data, right? How many people infected the first week, then second week and third week. Then they see how many will be infected, then use stats to do the feeding to find the formula. Okay, then you can do the prediction. So it says T is in the week, and the Y sub 0 is the initial amount at T equals 0. Okay, then they want us find in how many days we can expect to have so many people. That's how they did. Say, oh, how many people? 1 million people would be infected by, at that time, by August the 8th or something. Okay, because they developed the formula. Then say they have 500,000 people. Then how many people? When they get to million, how long it will take time to get to the million? Okay, once you have a formula, then you can use this prediction from 20,000 to 45,000, how long it will take, right? Use this formula. Then we want to find out how long. So how we are going to apply those? So what do you think? What's your Y? Y is the final result, right? Then initial is 20,000 people. That's your Y sub 0, 20,000 people. Then you use this formula. T is your variable, the time you are going to find, right? So we want to solve it just like we were saying, exponential equations, right? Different base. So you have to get one base by itself. So you divide by, get rid of this. So what do we have? We have 2.25 equals simple exponential equation. Then what do? We cannot make the same base. Then we have to rewrite it to the log. You have log base E, right? What's in the middle? What's outside? So you hook it, right? So you hook to the outside to get inside. Then how do we find this value? This one is a natural log 2.25, which is on your computer, calculator. So what's your T? T would be natural log 2.25 divided by 0.75, right? Then you continue, then you find out is what? It's about 10.8124028. What is T? By the days, by the weeks, by the month, by the year? Take a look. It says what? The rate, 7.5% is what? By the week. Okay? So if by the week, that means this would be the 10.81 weeks. The question is, they are concerned about how many days from 20,000 to 45,000. So 1 week would be what? 7 days, right? So you times 7 for it. It's about what? 76 days. Then about 2.5 months, they grow more than double. It's a major concern, right? So it's about 76 days. They can expect 45,000 people to have flu. So they have to manufacture vaccine, all that, to get ready. Right? Are we okay? How to solve our logs, solve the exponential equations. All right, it has a lot of applications in the real world. So that would be our section 10.5.